Halogenoalkanes. Okay, the organic family of halogenoalkanes. Well, if we examine what's in the name, halogen is at the root of it, and that's because these are essentially substituted alkanes. They are alkanes that have a halogen atom attached to them. So this can be a fluoride, or a chloride, or a bromide, or an iodide. And so in naming them, we give them the prefixes, it's the, what is it? For the suffix fluoro, suffix chloro, bromo, or iodo. Iodo. That's kind of, I like that one, iodo. Actually, these are actually prefixes when I think about it, because you put them at the front. So those are prefixes. So, well, we'll go through some examples on naming halogenoalkanes. Alrighty, so let's say we had a carbon chain like this with a bromine substitute. I'm not going to write all the hydrogens, but you'd count the parent chain as you do. See that the parent chain is 4 carbons long, so that's going to be a butane. So this would be called 1-bromo-butane. Alright, let's say alternatively we had maybe a couple of them on there. Maybe we had a bromine substitute and an iodine substitute. Then the name of this one would be, and of course you can pause it and try it yourself before I reveal it, but this would now be parent chain 3 long, so it's a propane. So this would be 2-bromo, 1-iodo propane. A couple other things, like why did I do that? Why did I number it? Why do we number it? Not just me, but those are the IUPAC rules, of course. Why do we number it 1, 2? Well, the alternative would be 2, 3. So 1 and 2 are smaller numbers than 2 and 3. So that's the way we do it. Give it the smallest numbers possible. Why do we write the bromo before the iodo? Well, it goes alphabetical. B comes before I, so we put the 2-bromo before the 1-iodo. Couple more halogenoalkanes. By the way, sometimes they're called haloalkanes. You might see that, but by IB terminology, we call them halogenoalkanes. So we don't actually use this term. We call them halogenoalkanes. Anyways, that's by the by. What if we have something like this? Let's get a pentane parent, and let's get a couple of fluoro substitutions. And we'll put a chloro there too. And we'll try to properly name this bad boy. So we have the parent chain is 5. It's a pentane. And we see substitutions at 1, 2, and 3. So C comes before F in the alphabet. So the 1-chloro is going to go first. That's 1-chloro. Then it's going to be 2, 3 difluoro. And my page is not long enough for this name, but it would continue, difluoropentane. One other word on halogenoalkanes. They can be primary, secondary, or tertiary. So a primary halogenoalkane, this would be an example of a primary halogenoalkane. This would be 1-bromopropane, or you might just call it bromopropane, and you would assume it's at carbon 1. This would be an example of a primary halogenoalkane. Why? Because this carbon, where the halogen is attached, is a primary carbon. So that's a primary halogenoalkane. And we said it would be called 1-bromopropane. Okay, so a secondary would mean that the substituent, halide residue, whatever you want to call it, would be attached to a secondary carbon. So there's a secondary carbon. So in this case, you can see that carbon right there where the bromo is attached is a secondary. And the name of this thing would be 2-bromopropane. 2-bromopropane. Then we could have a tertiary as well. We just have to make the bromo attached to a tertiary carbon. So we're not going to have enough carbons if we try to make it a 3-carbon compound. We'll have to add a kind of a methyl group on here. So once again, if we were trying to name this, well, let me crawl before I walk here. There's your tertiary carbon. So this would be a tertiary halogenoalkane. And the longest chain is still a propane. So this is going to be a 2-bromo 2-methyl propane. 2-bromo 2-methyl propane. And you're sorted.